All right, guys. So today we want to look at fractions. Now we would have looked at integers before now, and we know that the number system, it consists of various types of numbers. And the first one that we actually look at was integers. Now, fraction would fall into the category of a different type of number. Anybody know what category fraction would fall into? What type of number?
Rational numbers, sir.
Rational numbers, all right. So today we're going to be looking at fraction as rational numbers. And so just as before, we should be able to carry out the 4 operations on fraction, meaning that we must be able to add them, subtract them, multiply them, and divide them. All right, so I know that most of you, if not all of you, should have already met fractions, and you would by now know, I should by now know what a fraction is. So we're going to start off with that. Want to start off with a definition for fraction. So anybody want to give me their view of what a fraction is? Just raise your hand and let me call on you to decide who to go and give me their answer. So what is fraction, students? Anybody? Raise your hand. All right, go ahead, Mr. Campbell. What's a fraction?
A fraction is a part of a whole, sir.
Fraction is a part of a whole. All right. Trivia, what's your take on that? Go ahead. Trivia, are you hearing me?
A fraction consists of a denominator and a numerator.
All right, a fraction consists of a denominator.
Yes, sir.
Now, a fraction, as we say, would be rational, and based on the definition for rational, there is always a numerator and a denominator, where the denominator cannot be equal to 0. All right. All right, you can lower your hand now, Ms. Sylvia. Anybody else want to say anything else about fraction? All right. So the definition of fraction is a part of a whole. And that's what a fraction is. But when you think about the definition, and we say fraction as a part of a whole, we remember that whole numbers are what kind of numbers again? If we are to define the set of whole numbers, what would they be?
Natural numbers, sir.
Say that
Whole numbers.
again. Whole numbers are what kind of number? How can we describe whole numbers? What are whole numbers? Students, what are whole numbers? Anybody? All right, let me ask persons. Ms. Cummings, what are whole numbers?
Natural numbers and 0, sir.
Right, so natural number together with 0, all right? And remember, natural number is just another name for counting numbers. All right, now what we know about natural numbers and whole numbers, they are generally the positive numbers, right? So if we say a fraction is a part of a whole, we are thinking about a whole as a complete unit, a complete thing. All right. Now, there are many things that we can regard as a whole. We can consider a whole pizza to be, well, if we are all familiar with pizza, we can consider a pizza. If we say a pizza, we are considering a whole pizza to be a circular, how would you describe a pizza? It would be something like a circular pie where you cut it up into different parts, right? And so if you cut it up in different, let's see if I can illustrate what I'm saying. So if you have a whole pizza and it is cut up into various parts, let's say we cut it up into 8 equal parts. This is not a perfect drawing, so we just are kind of using our imagination here that we have a perfect drawing, so not drawn to scale. All right, so here we have a pizza and we cut it up. How many slices we cut up the pizza in?
8, sir.
8 equal parts, all right? And so the entire pizza would be the total number of slices that make up the circle. But if we should take a part of a whole, meaning that we should, if we take out a slice, or say 2 slices out of the whole, then actually what we will get is a fraction. Now, the area being shaded, how many slices are we shading?
2, sir.
So how would we write the 2 slices? If we were to write it as a fraction, how would we write it?
2 over 8.
We'll write it as 2 over 8. Now, 2 over 8, what that means in terms of the fraction. If you see 2 over 8, what that tells you.
2 was taken out of 8 parts, sir.
So it means that you get 2 parts out of a total of 8 parts. All right. Now, the 2 tells you how much part you have, or how much part is taken out of the whole. So the 2 is generally the numerator. So the numerator tells you how much part you have out of the whole. All right, let me just use that as a numerator. And this down here we call this what? The denominator. Now, nothing new. Everybody's supposed to know what they are doing. Now, with this said, we know that the denominator tells you how many slices you have in total, and the numerator tells you how many slices you have as a fraction of the whole. All right, now, can this fraction 2 over 8 be written in a simpler form?
Yes, sir.
What could we write this as?
1 over 4.
we could write it as, we write this as 1/4. And anybody agree? Raise your hand if you agree that we could write this as 1/4. Okay. Now, are the two fractions the same? Are they the same?
No, sir.
Who answered just now? Miss Waysome or Miss Cummins? Who answered? Miss Cummins, are the two fractions the same?
Yes, sir, I think so.
Okay, so the two fractions are the same, but what you notice, how are they different?
Sir, is it that one is in its simplest form and one is its largest portion?
Well, I wouldn't say it is one is in the largest form and one in the simplest form. We see that both of them are written with a different denominator. And we realize that if we're writing with different denominator, what are we saying about the fraction? So this one has a denominator of 8 and this one has a denominator of 4. So the 2 parts out of 8 is the same as the 1 part out of 4. And so the question is, why do we consider them to be the same if the denominators are different?
So they are equivalent.
They are equivalent. Everybody agree that they're equivalent? So what it is really saying then is the same 2 slices would be equivalent to 1 slice if you cut it into 4 equal parts. 2 slices when you cut it into 8 parts would be equal to the same slice if you cut it up into 4 equal parts and you take 1 slice out of 4. So 1 slice out of 4 is the same as 2 slices over 8. Everybody agree with that? Raise your hand. All right, good. All right, so with all of that said now, let me clear all that. All right, let me clear this. So let me ask you now, students, what are the different types of fractions that you know?
Proper, improper, and mixed fractions, sir.
So we know proper, improper, and the other one is?
Mixed fraction.
All right, mixed fraction. Now, oftentimes people say mixed fraction. I rather to say mixed numbers. All right, now, proper. A proper fraction with the numerator smaller than the denominator. Now, why is it that we call this the fraction where the numerator is smaller than the denominator? Why do we call this fraction proper? I'm waiting. Anybody?
Sir, a problem because the numerator can go into the denominator.
You know, I'm not really hearing you so clearly. Could you go again?
I was thinking that maybe it's because the numerator can go in the denominator.
Because the numerator can go into the denominator.
Yes, sir.
All right, that's an observation. But think about it some more. Anybody else want to share their views? Anybody else? Why do we call a fraction where the numerator smaller than the denominator? Why we call that fraction proper? I'm waiting, and I'm listening to hear some answers. All right, looking back at the same shaded region of this pizza. It is what? 2 out of 8.
Sir, is it because the smaller the denominator the numerator was taken out of the denominator? I'm not sure.
All right. Anybody else want to add anything to what Ms. Wilson is saying? Is it because the numerator is taken out of the denominator? Anybody agree with that? I think it was the same thing there the person before was saying. Was it that you were saying? Who was saying that? Was it Mr. Campbell, or was it Mr. Campbell who was saying the same thing?
Repeat, sir.
Were you saying something to that effect just now? According to what Ms. Wason is saying. Ms. Wason, go ahead, Ms. Wason. Say what you said just now.
I was saying, sir, because the numerator was taken out of the denominator.
Because the numerator is taken out of the denominator.
Yes, sir. I was saying something along those lines.
You were saying something along that. All right. So, so if you think of the definition of what a fraction is a what? A part of a whole. Now, as Ms. Wason said, because we take 2 as a part of 8 slices, we take out 2 slices as a part of 8 slices, then we can say it is proper where the numerator is smaller. We know that we have a proper fraction. All agree? Do you all agree? Raise your hand. Now, suppose you have a fraction. Suppose we have the fraction suppose we have the fraction 9/8. What kind of fraction is that?
Improper.
Improper.
It is called what?
Improper.
Improper.
All right, why is this fraction improper now?
Because the numerator is larger than the denominator.
Yeah, we realize that the numerator is larger than the denominator. But think a little deeper than that. Why would a fraction where the numerator larger than the denominator, why would we call it improper?
Because we can't get the numerator out of the denominator, sir.
Well, when we think of fraction as a part of a whole, then to say that 9 is a part of 8, it seems like a contradiction, right?
Yes, sir.
All right. You can lower your hand, Miss Wasom and Miss Travia. Miss Travia, you want to say something?
No, sir.
Okay. So it doesn't seem proper to have a larger number out of the denominator, because the denominator actually tells you the total number of slices that the whole is cut up into. And to try and get 9 parts out of 8 would seem impossible. But we say that it is improper. Now, in order to get an improper fraction, 9 out of 8, could we get it from one pizza? Can we take 9 out of 8 from one of the pizza?
No, sir.
No. In order to get 9 out of 8, then we would have to have what? We would have to have what, students?
In order to take 9 out of 8, sir.
Right. In order to get 9 out of 8 as a
Sir,
fraction.
you can't get 9 out of 8, sir.
You can't get 9 out of 8. But in order to, what the numerator tell you how many slices of the pizza is cut up into 8 equal parts, right? So we are saying that each of these slices would be the same in size. Now, if we have 8 parts out of 8, how many pizza we have?
1.
And if we have 9 parts out of 8, how many pizza do we have? Anybody? Can we share one pizza and get 9 parts out of 8?
No, sir.
So how can we get 9 parts out of 8?
Sir, that would give a mixed fraction.
How can we get it? Just tell me, if you were to share, if you are sharing pizza among 9 persons and you want all of them to get an equal slice, which is 1 slice out of 8, what would you do?
Sir, that you cut off piece off it, like, but it's slice on at the end, it's slice on become equal. Or you'd have to probably well you'd have to cut off piece off of each slice, sir.
All right. So
But it wouldn't be 8 anymore. They end up with 9 slices if they're gonna do it equally.
So how would you get 9 slices out of 8? Miss Green, you want to share anything with us?
Sir, may I try to think about it, sir? Come and sit down, we forget 9 out of 8.
Scott, how can we get 9 slices of this
I'm not sure, sir.
slices? How would we get 9 slices where the slices are all the same? Mr. Ajena, are you there? Seems like Mr. Ajena mic is a problem. Trivia,
Yes, sir.
what do you say about this situation? How if you have a pizza and you cut it up into 8 equal slices. Now you have 9 persons that you want to give pizza to, but you want all of them to have the same slice, same size slice. What would you do?
Reduce the slices to a smaller amount.
No,
And,
you still want it to maintain the same slice. You don't
so,
want
sir,
you don't
so
want
you
to
would take,
change the slice. Everybody
you
wants
would,
the same slice.
but you would take equal portion of each slice.
They take equal, but it's not going to be the same slice that everybody going to get. Everybody want the same slice of pizza.
So you would share it, reshare it. So I'm not sure.
All you need to do is get another pizza and take out another slice. So this pizza will give you 8 slices. You get another pizza and take out one of these 8 slices. Now you get 9 slices out of 8. Do you agree, students?
What you said, so you add one, get another pizza.
Yeah, get another pizza and take out one of the slices. And now you have 9 slices that are the same as one slice. You agree? Because remember, now, this pizza is cut up into 8 equal slices. And you want another slice, which is the same as this side. So you get another pizza that is cut up into 8 parts, equal parts. Take out one of that slice and add it to this. You get 9 slices. Do you agree?
Yes, sir, but it wouldn't be the same as with the mixed
Oh, sir,
fraction,
we
then
don't
where they have
understand.
1 whole and then 1 out of 8, sir, as I was saying earlier too.
So that Miss Wilson again.
No, as I was saying earlier when I mentioned the mixed fraction about 1 and 1 over 8, I'm saying you'd have 1 whole pizza with 8 slices, and then you have the next one where you have a 1 out of 8 for that one.
Right. So we're saying, we're not talking about mixed fraction, you know.
I know, but the idea just came to me and I was...
We're talking about how can we get 9 slices out of 8? So the idea is that you really can't have one pizza that's going to give you 9 slices that is the same size. You see? So this is already 8 slices out of 8. To get another slice out of 8, you need to get another pizza that is cut up into 8 parts. You follow what I'm saying? Just as this one. Now, for that reason, you now see why it is called improper. Because based on what a fraction is a part of a whole. But you cannot get 9 slices out of 8, meaning that you can't get 9 slices out of 1 whole pizza. You would have to get another slice from another pizza to get 9 slices. But we're still going to put 9 slices over 8 because 1 slice is 1 over 8. And if you have 9 of the same slices, we're saying that we have 9 times 1 over 8, which is 9 over 8. So 9 over 8 really means that you have 9 pizza, which are all the same slices as when you cut up the pizza in 8 parts. That's all it is saying. So because we are not getting the 9 slices out of 1 whole pizza, we have to get another pizza to get another slice. Then that's the reason why it is called improper. because based on the definition of a fraction is a part of a whole. And 9 out of 8 is not a part of one whole pizza. It's a part of 2 pizza. So you have to use actually 2 whole pizza to get 9 parts. You following what I'm saying, guys?
Yes, sir.
Yes, sir.
So if you are now to consider this pizza, this portion, we call it an improper fraction. Now back to what Ms. Wilson was saying about improper fraction, we realize that if we are to get 1 whole out of 9 out of 8, we could just take, we see that the denominator tell you how many slices the whole pizza should have. The pizza should have how many slices? 8 slices in total. So 1 whole pizza gonna have 8 slices. So if this has 9 slices out of 8, it means that we can write it as a mixed fraction, as Ms. Wilson was saying, or a mixed number, because we can take 8 slices out of 9, which will give you 1 whole pizza, and how many slices you would have remain? If you take 8 out of 9, how many slices you have? Remain. You have 1 remaining, and so we call, and then we put back that 1 over 8. Everybody see what I'm saying?
Yes, sir.
So the 1 here tell you that you have 1 pizza plus an extra slice. So that is 1 and 1/8. And that is what we call a mixed fraction or a mixed number, right? Now, the denominator over 8 really tell you that we are dealing with pizzas that are cut up into 8 parts. So this 1 over 8 comes out of a pizza that is cut up into 8 parts, right? And so if you have 1 whole pizza with 8 slices out of 8, plus an extra slice out of 8 from another pizza, now you will have 9 slices over 8. And we keep the 8 because we know that all of these slices are the same. All right? So that's the idea. That's why we call it improper, because this does not truly represent based on the definition of a fraction, because 9 is really not a part of 1 whole pizza that cut up into 8 slices. It's actually a part of 2 pizza, 1 whole one plus 1 slice out of another one. All right, so I hope you guys are getting the idea behind it, why we have proper, why we have improper, and why we have mixed. Any question, students? Is it clear to you now? Can you raise your hand if you're clear on what I've been saying? All right, so I saw only 1 hand. That means the other persons are not sure. Miss Scott, what are you not clear about? Miss Scott, are you there? Can you say something to acknowledge that you're hearing us? Are you hearing me?
Yes, sir, I'm hearing you.
Okay. What is it that you're not clear about? All right. Let me ask another question. What is if you let me shade a region. So suppose I shade this region. How much pizza would that represent? What fraction would that represent?